So thank you for that introduction. I wish I could be with you in person, but my name is Nick Ward. I'm the VP of Digital Systems at Rolls-Royce. So what that really means is that I look at our whole digital journey from working with our customers for data, for understanding our fleet, for interacting with our maintenance and overhaul bases, and collaborating with customers and suppliers to find opportunities for value. And I'm going to take you through a story that we've been several years in the making now around a program we call the Intelligent Engine. It's about doing many things, but if it had to come down to one thing, it is about maximizing the time on wing of the engines for all of our airline customers. Time on wing is, in the simplest sense, it's revenue. It's about passenger miles. It's about really delivering the mission, maintaining the schedule with a minimum amount of cost. So how do we do that? What is the Rolls-Royce vision behind this? We need to be fully embedded with our airlines, with our suppliers. We need to make sure this is an industry that works together. We need to make sure from our side that we understand the fleet. We need to know what's going on in the fleet in order to make our predictions and our maintenance schedules and all the work that we need to do and connect back with our customers at the right moments. So we have this, right? This is the Rolls-Royce digital backbone, our digital system, and it's about four major steps. It's about connecting to our customers, to our partners, and to our supply chain for data. Without data, we're blind. If we're blind, we can't try to improve the design of the engines, the operation of the engines, the availability of the engines. So we need to know what's happening. And we have a whole part of our system, our strategy, around connecting better, seamlessly, in an automated way, in a two-directional way with our customers, our partners, and our suppliers. So that gives us data. Once we have data, we can make all the predictions we need to make about the life, the condition of the fleet. And from that prediction, we can do a load of things. We can support the availability of the engines on wing. We could also create the demand signal for maintenance. That demand signal will go back into our internal systems. We then will plan that. We will execute that through our maintenance and overhaul bases. And in the end, the engine comes back out of that process, and we need to share the state of the fleet, the condition of the fleet, the forecast of the fleet, all the information you need in order to be the operator of that equipment within the airline industry. So we have to have a collaboration strategy as well. So these four hexagons, these four pillars of our backbone form our digital strategy, which is designed to be plug and play, be as interactive and involving as we can within our industry, and to sort of use all the strengths of everybody around us. And the major shift, I think, here is the tagline at the bottom. It is about using the processing power of digital technology, the cloud and AI and all of those great things to treat every engine as an individual, but also to treat every customer as an individual. Our customers fly these engines in very, very different ways. They experience very different lives. And what we need to do is tune the maintenance intervals, the requirement for life limits, for inspection intervals, all of those things we have to do in the MRO world. We need to tune that to the specifics of that customer and the specifics of that engine. And that's how we design out conservatism from the process. So if I just make that a little bit more real, then this is how this translates into some of the language that I'll talk about and some of the things you may have seen already and experienced as a Rolls-Royce customer. So our connect strategy, we call this the blue data thread. It's, if you imagine, if you will, a thin blue thread that connects every aircraft and every engine to Rolls-Royce. It connects our airline customers to Rolls-Royce, and that thread is humming with data all of the time. But it's a very easy thread to incorporate. It is plug and play. It is automated. It is seamless. It is two-directional. So as we receive data, as we need in order to understand the fleet, we also need to be providing data back into the airline, back into the heart of the airline systems, the planning processes, all of those things. And in fact, on the latest business aviation engines that we have out there, our Pearl family, we can even talk right back to the engine, and we can make requests for specific data sets, again, based on the unique characteristics of how that engine is being used, what it's flying through. So the Blue Data Thread is a massive program which we're rolling out right now. A number of airline customers are already plugged into that and operating with us in a fantastic way. That gives us data. That data flows into our intelligent engines, our big data cloud system. I'll tell you a little bit more about that in a moment. But the intelligent engine's first and most important job is to help keep the engines on the wing. So time on wing is the most important metric that we measure by that. There are dimensions as well of avoiding unplanned costs, so monitoring the health of the engine, looking ahead, making sure we're not going to get delays or cancellation signals on the departure board as you're walking through the terminal doors. You want to see on time every time, particularly where it's a Rolls-Royce powered aircraft. We use the intelligent engine to look for those opportunities to avoid unplanned outages of availability. And all of that helps with the whole customer experience. And the longer we're keeping the engines on the wing, the less we are needing to take those off and ferry them around the world and do maintenance and overhaul and consume parts and labor and all of those things, the greener the service becomes, the greener the airline industry becomes, because we are purely flying when we need to be flying. But eventually, those engines do need to come off the wing at some point. Eventually, it's going to hit a condition or a life, which means we have to take the engine off. And the demand signal of when that's going to be, what it needs to come off for, what work we have to do, that comes from the intelligent engine as well. It goes through our service management process, which is where we actually form the plans, we instruct the maintenance bases, we induct the engines, we do the work, and we return the engines back to service. But again, being smart, knowing exactly the life, the health, the conditions that engine has seen, means that we can be very exact in things like our inventory levels. So we're not building and shipping parts we don't need. We're not creating maintenance capacity we don't need. So again, there's green credentials around all of this, which is great for everybody. And then eventually our final part of this, where we collaborate with customers, you'll increasingly see this in the media, and hopefully you'll experience it for yourselves, is we have a new capability called UCova, which is, if you like, a new tech startup platform. Feels a little bit like LinkedIn, feels a little bit like a marketplace, feels a little bit like a customer portal, but it's the way we want to draw everybody together. We want to be bringing Rolls-Royce very much into the center of the airline world. You know, the day in the life of a power plant engineer within our customer needs to feel like Rolls-Royce is part of that day to day and not something separate, something different, something to one side. We need to be really embedded, and UCova helps us do that. But I'm going to focus on the first two of these. I'm going to focus on the Blue Data Thread, the way we connect, and I'm going to focus on the intelligent engine, about one of the ways that we create value through this. And we're working in this space with one of our partners, IFS, who's kindly made this opportunity available. So perhaps the first thing is, why is time on wing so important? Time on wing is one of the major metrics that we in Rolls-Royce focus on. This is something we spend a lot of time, a lot of effort, a lot of money trying to improve. But why do we do that? And if you're in the airline business, if you're flying aircraft, this will be obvious. But perhaps an easy analogy is, if you're a taxi operator, if you're a taxi driver, you're driving around the cities, you make more money fundamentally the longer your taxi is driving, because you're earning fare money. You spend less money the fewer times you need to take that taxi out of service and into the shop. So the combination of time on wing, more revenue earning opportunity for the airlines, more passengers being carried, more cargo, fewer times in the shop, less cost, which is ultimately shared with Rolls-Royce, then the better. So this is why time on wing has this great double impact on two sides of the balance sheet. revenue and the cost. So I talked a little bit about the intelligent engine, the fact that it is our cloud-based platform. This is exactly what it is. It is a big data platform. It is in the Microsoft Azure cloud. It gives us fantastic processing power, almost unlimited processing power. You can turn it up, you can turn it down as you need to. It gives us fantastic capabilities for artificial intelligence. It deals with all of the big data challenges that we have. It also, as I briefly mentioned earlier, has Internet of Things connectivity back into our most modern aircraft engines. But in the end, it is a platform to do a job, and what is that job that it's trying to do? And I should say perhaps as well that one of the biggest challenges we've had in moving a lot of this capability, Rolls-Royce has been around a long time, we've done some of these things in earlier stages of maturity, but moving this into the cloud is how do you do that while maintaining the security and the integrity of the data that sits within this. So while it's the cloud and while it's Azure, it also has a very strong Rolls-Royce security bubble around it, if you like. So we think this is one of the most secure cloud environments that certainly that I know of out there across all industries. But it gives us that processing power. And in order to leverage that, in order to apply all those artificial intelligence models, we need to feed the beast with data. And this is the blue data thread portion of the system. So we have to feed data into and out of that cloud system. So as soon as we're entering service with a new design, and by the way, even before we get to this stage, we're using a lot of those predictive models to feed back through the design process to make sure that we understand exactly how that component is going to work and survive and last and really maximize its service time. But once we do get into that service period, then we need to be connected for data. And you can see the two major flows here. It's connecting to the aircraft and the engines. We've always done that in different levels, but moving past simple snapshot records of what's going on, maybe half a dozen data points for each parameter through a flight, that's okay for long-term trending. But what we're really moving to now is every flight, what is the continuous record of what that engine's been doing? So if you like, the data that's recorded at 1 Hertz, 5 Hertz, and you'll know these things as CPL, SAR, DAR, QAR, various flavors of that data. We're working through the blue data thread with one of our partners, CETA, to help make that a very simple, controlled, and safe process for airlines to share that data with us. But equally, as we take that data into the intelligent engine, there's a mechanism to then apply the models into that sort of higher frequency data, get really into the depths of what is going on in that engine, what's happening with that shaft speed, what's happening with the vibration, what's happening in the neural system. Can we use that to identify any potentially emergent issue that may somewhere down the line lead to a delay in a flight? We want to get on top of that. Can we use that data as well to understand the life consumption of some of those parts? I'll explore that a little bit in a moment. But the second leg of this, and you can see at the bottom, this is my representation of an airline. I know it's really the airport, but go on, bear with me. So we need to be connecting as well to the airline system. We need to understand the embodiment of any modification service bulletins. We need to know the utilization of the aircraft. We need to know any maintenance information that may have happened on the line. We need to know what's going on in the tech logs for any reliability issues. It's basically, we need to get a little bit of an eye into what's happening within the airline's own maintenance record around the engine. We use that data combined with the aircraft engine data to understand how life is being consumed through the life limited parts and the non-life limited parts. And once we've got that, we need to be able to pass that information back directly into the heart of the airline system, so that it's not just us as Rolls-Royce can see where the life of that part is and perhaps the forecast of that engine removal, but we have exactly the same view within the airline planning system as well. So we need to make sure we are we are plugged in as seamlessly as we can right into the center of that. And this, in the end, this is the blue data thread concept. And I mentioned that we're working with partners, we're working with CETA, which everybody will know, but we're also very much working with IFS in this space. So IFS has a fantastic system, Maintenance, which many of you will be users of. It lives in the airline system. For airlines who are operating Maintenance, we've worked with IFS to create a plugin, a feature, which does all of the data preparation that we need, automates the exchange of that data back into the Rolls-Royce Intelligent Engine. And the really good bit, the really value add bit is it then receives those updated state of the fleet back into Maintenance, back into the planning system. So that, again, we have the same view at the glass within Rolls-Royce, within the airline, enabled through the Maintenance and IFS. And clearly, not everybody is a Maintenance user. I'm sure IFS would be very pleased if you were, but we also replicate this with the other major maintenance management system vendors as well. So that's a little bit about how we connect, and perhaps just to leave you on one very significant use case that helps us do. If we look at life limited parts, so every engine will have within it a series of parts which have a life limit. It's a definition, it's obvious, right? So a life limited part has a certain number of cycles, a certain amount of units of life that it is allowed to stay in the engine. And when you reach that limit, you have to take the engine off. It's a removal driver for the engine. So you can see here two alternative ways of thinking about this. So we have the traditional way, which is the red aircraft and the red arrow. This aircraft is doing a flight. One flight is equating to one cycle of life. These life limited parts typically between 3,000 and 5,000 cycles when they hit their life limit. So every time we fly, we're consuming 1 unit of that life. And you can see the rate of growth of the red arrow gets to point A, hits the life limit at a certain amount of flying time. But that's like we're flying blind. We don't know, as the OEM, we don't know how intense that flight was. We don't know, going back to maybe the taxi analogy, we don't know whether you drove everywhere in third gear and you've got a load of weight in the car and it's the worst possible drive you could have and you're really wearing your engine out. We don't know that, versus you could be driving everywhere very smoothly, nothing in the back, very lightweight, driving in fifth gear, everything is as efficient as it could be. The way we understand that is through data, through the blue data thread connection. And at that point, we can start to understand, actually, green aircraft, green arrow, we can understand that that flight really only consumed maybe half a cycle's worth of damage on that particular life limited part. And over the course of thousands of flights, we will find that we accumulate that life at a slower rate because we can demonstrate and we can justify that the parts are wearing out at a slower rate than we would otherwise conservatively have to guess. And we reach the life limit at a point further down the line. And the translation of that is more flying time, more revenue earning flying time for that engine on that aircraft. And you can see at the bottom here, there's a bit of an average statement here, but around about 40% of the engine removals right now are driven by life limited part expiry. And between a couple of our modern engines, which use this, the Trent 1000 on the Boeing 787, the Trent XWB engine on the A350 aircraft, we're getting around about 50% more flying time just because we have this window of data into what's going on, and we can extend that flying time massively by 50% before the first refurb, which is incredible. And it's all enabled by having that data visibility, the data connection, the smart algorithms that work within the intelligent engine, and the ability to push the result of that back into the airline planning system so that we can take advantage of that gain. So just one example, and there's many, many, many more. whether we're looking at turbine blade deterioration or any other part around the engine, we can do very, very similar things. And perhaps to leave you with one final thought on this, we often look at this about its revenue and its avoided costs and its great financial metrics. But if you think purely about the planet and the sustainability of our industry, doing all of this kind of stuff is really, really important, and it becomes transformative on our journey to net zero. So there's a little bit of a factoid here where we can avoid something like 200 shop visits a year simply by understanding the condition of the engine and demonstrating it can stay on the wing. If we do that, and we're avoiding having to ferry those engines from wherever they are around the world via cargo aircraft to overhaul shops and return flights, we can save between 10 and 30,000 tons of carbon a year. Doesn't have to go into the atmosphere. And that's equivalent to 15,000 of those taxis at the start of this. So great for revenue, great for cost, brilliant for the planet. And this is part of our mission.